Hey, welcome everyone to course on fundamentals of convolutional neural network. In this course, we are going to learn about how we can use convolutional neural network to classify images, right? So what we are going to do is, given an image of an animal, here we are going to take an example of a dog versus cat. So we are going to train a machine to classify which image is a dog and which image is a cat. So for us as a human being, it's very easy to classify those images, but for machine, it's not that easy. So we need to train our machines to classify the images into dogs and cats, right? So that is what we are going to do in this particular course. So what is the CNN? It stands for convolutional neural network. It's basically a deep learning network which uses deep learning technology, which is a subset of machine learning for classifying images. So the work was started way back in 1959 by Hubel and Wiesel, but the progress was not done in a timely manner. Like, it took a lot of time to get to a working model, because at that point in time, the computing resources, the amount of data that's available was scarce. So training a model what was a huge intensive task. By the time it around 1989, Jan LeCun has developed a backpropagation technique which allowed for automatic learning for the machines based on the image characteristics. And don't worry if you are getting bogged down by terms like backpropagation. We will learn about that in the deep learning section. Okay. Then Jan LeCun successfully experimented that CNN network for identifying the handwritten digits on the US mail, where like usually people write the address and the zip code in handwritten digits. So Jan LeCun identified a technique by which it can automatically recognize those letters, regardless of everybody writes the same digit in a different manner, right? But Jan LeCun CNN network could recognize that, and that allowed machines to be used for sorting the mail, right? Then once we have machines who can classify the images, it can scale really well, and it can do millions and billions of image classification in a matter of few minutes. So other than image classification, convolutional neural network, one dimensional network, is also used in natural language processing, stands for which abbreviated as NLP usually, and that is used for understanding the relationship between the words, right? So CNN is very popular. In fact, if you take a look at a lot of pre-trained networks that you might have heard, like ResNet, VGG, 16, Inception V3, those are all variants of CNN, right? And those networks have won a lot of ImageNet competitions in recent years. So what are the benefits? Basically, CNN trains machine to classify images, so it can scale really well. It can automate the image classification, and we can extend this to even for videos. And it can scale for millions and billions of images in a matter of few hours. So you can write an automated program once your model is trained, and use that model to classify a corpus of billions of images into a matter of few minutes. And you can train the networks to classify any images, right? As long as you have a data labeled data where you know that for this set of images these are the labels, then machine can use the exactly same algorithm to classify many types of images. It could be dogs versus cat, or specific breeds of dog. It could be used for classifying, let's say, Simpson characters, who's the character in the current video frame. It can do that also. So the possibilities are immense. So in this particular course, I do not assume that you have any background in machine learning, deep learning, or CNN. We are going to start very slow. Okay, I'm going to start with the fundamentals of convolutions. Okay, what is the convolution operation is all about? Then what is the deep learning is all about? Then I will talk about CNN in little bit detail. We will go through the architecture of the CNN and understand what are the pooling, what are the pooling layers, what are the fully connected layers, and what are the output softmax layers, what is the purpose of each and every layer in the network. Having this fundamental knowledge is crucial for fine-tuning your network. Once you understand what are the different layers, you can fine-tune the networks on your own. Then we will train a model uh, using dogs versus cats data from Kaggle. We will also fine tune the model. Then I will use an interactive Jupyter notebook where I will walk you guys through a step by step code on how to train the model, how to create a data which is suitable for training an ML model. And then we will save that model, and then we will build a real life web application where we will use this trained model to classify dogs versus cats images. So let's look at a demo. So towards the end of this course, we are also going to build a real life web application where you can upload an image of your choice and the model will tell you whether that's the image of a cat or dog, right? So here's how the web application will look like. It says it's dog versus cat classifier. It gives you a button to choose a file and then upload the button to the server. Then the server side, the server is on this your machine for the purpose of this course. Then there will be a Python code invoked when you click on the upload button, and the model will parse the image and will predict the category for it. Okay, so let's choose a file. So this is a nice image of a dog. Let's upload and let's tell our model. So model is showing this image and it's classifying as dog. Let's try one more image. Let's see, this is the image of a cat. Let's see if our model is able to predict it. Yes, it's predicting correctly. We can try one more image. It's predicting nicely. So this is the example that we are going to build, and I will walk you step by step through the program, and we are going to reuse whatever we have learned in Jupyter Code Notebook and just convert it to a web application and just use the same trained model to classify the animals. And then you can use this application to brag with your friends, or you can also, if you're working for as a machine learning developer in a company, you can use this technique to classify any other set of animals also if you would like, right? Or for that matter, any other set of images. It could be food images, it could be vehicles, it could be any other image that you would like to classify. The fundamental principles of using CNN would remain same.